My name is Phuah, and this is my question 2. My new research question will be, is there a statistical linear relationship between the body weight and BMI of UMS male students? Experimental design will be one gender, which is male, two variables, which are body weight and BMI, one sample for each group. Sample size is 10 students. Body weight and BMI were obtained from each student. I'm using simple linear regression tests because the data collected are scale data. There may be a relationship between the two samples. The data collected are only from one gender, so the original research question cannot be used. The data are normally distributed. This is proven by the Shapiro-Wilk test using the R calculator. The name of response variable X will be weight, response variable Y will be BMI, and these are the datas. And this is my table for data. And this is how the scatter plot with the line of best fit looks like. Now I'm going to show my R script. First, I set up my working directory. Then I read my CSV file. I converted the student ID into factor. And this is how the structure of my data looks like. My data consists of 10 observations of 3 variables. Next, I summarize them. Then I carry out the Shapiro-Wilk test to test for normality of the data for both the weight and BMI. The two values show that they are larger than 0.05, which means that the data are normally distributed. Next, I plot my data in a scatter plot. Then I make up a SLR model. My SLR model will show the value for the intercept and the regression, the coefficient of the regression coefficient values, which are 20.765 and 0.0665. Next, I insert the line of best fit into the scatter plot. Then I summarize my SLR model. My SLR model shows the estimated value, standard error, t-value, as well as the significant value for both the intercept and the regression coefficient. The R-square shows the percentage of variance explained by this model. The p-value 0.3018 is larger than 0.05, which means that the Bushnell is rejected, meaning that the relationship between the body weight and BMI of UMS male student is linear. And next, I'll show my ANOVA table, which consists of the degree of freedom, sum of square, mean square, F value, as well as the significant value for the BMI, weight, $ weight, which is the regression coefficient, as well as the residuals. That's all for my question 2. Thank you.